हेलो डियर स्टूडेंट्स, गुड मॉर्निंग टू एवरीवन। कैसे हैं आप लोग? उम्मीद करता हूं सब लोग फिट एंड फाइन, हैप्पी एंड हेल्दी होंगे। लास्ट क्लासेस में हम लोगों ने डाइपोल मोमेंट डिस्कस कर लिया था। डाइपोल मोमेंट के रिलेटेड हमने बहुत कुछ डिटेल में डिस्कस किया। आज आपके सामने मैंने एक क्वेश्चन डाला है, आप फटाफट से उसे सॉल्व कर ले और उसके बाद ऑफ कोर्स डेफिनेटली यू विल पोस्ट द आंसर इन द चैट बॉक्स एंड फर्दर वी आर गोइंग टू डिस्कस वन मोर इंटरेस्टिंग थियरी टुडे। आई होप आप लोगों ने थंबनेल में देख लिया होगा। टुडे वी आर गोइंग टू डिस्कस अबाउट द फजान्स रूल एंड थर्मल स्टेबिलिटी। ठीक है, चलो वो शुरू करने से पहले वी कैन हैव डेफिनेटली 10 सेकंड कंसंट्रेशन सेशन। लेट्स स्टार्ट। Okay, so now you and me and you both have been synchronized totally. So whatever will be delivered, that will be registered in your brain to a very long period of time, and that will help you out to increase your score and confidence both. Okay, focus on to the question and let's start the discussion as well. Now you can see in all these you can find there is a chlorine and carbon. The bond between carbon and chlorine is there, carbon and chlorine is there, and carbon and chlorine is there. So in each case I think you can understand the electronegativity of chlorine is more, so bonding electron pair remains attracted towards chlorine and carbon will be plus delta. Now we look at here, more the partial positive or partial negative charge develop on either chlorine or carbon. On the basis of that, polarity will be discussed. Now you focus on to this carbon atom, which is sp3, in which s character is 25%. In this is sp, in which s character is 50%, and this is what? This is sp2 hybridization, in which s character is 33%. So this compound has a highest S character. As highest S character is there, it will have highest electronegativity also, and as it has highest electronegativity, it will not allow this chlorine to pull the bonding electron much towards it. Whereas in compound A, carbon is sp3 hybridized, which has 25% S character. Its electronegativity will be least in all these A, B, C. So it will allow these chlorine to pull the bonding electron pair towards itself maximum. So these chlorine has maximum minus delta, and these chlorine has minimum minus delta, and these chlorine has intermediate minus delta between A and B. So the maximum minus delta is on A, minimum minus delta is on B, and further intermediate minus delta is on C. So in that case, maximum polarity A, minimum polarity B, and intermediate is C. So your answer should be A, C and B. Have you done the same? Let me know. Similar type of one more question we have already solved, like this. We have compared the dipole moment in both. Can you recollect? So this is what? This is benzene, and this is in fact chlorobenzene, and this is chlorocyclohexane. Now focus on to this bond, that this carbon is sp2 hybridized, this carbon is sp3 hybridized. This has 25% S character, this has 33% S character. This has more S character. As this has more S character, its electronegativity is more. As its electronegativity is more, it will not allow these chlorine to pull electron pair much, while this has less electronegativity. This has less electronegativity. This will allow this chlorine to pull the electron pair more towards it. So chlorine will carry larger minus delta. This chlorine will carry lower minus delta. So larger minus delta, its mu net will be higher than this. So it all depends on what? It all depends on hybridization. It's all depend on hybridization. Everyone clear? Let me know in the chat box so that we can start our today's topic. Okay. Now today's discussion is FAJAN'S rule. In many books, instead of this J, you may find Z also. We have already discussed the word polarization so many times. Polarization. Polarization means what? Deviation from original behavior. Deviation from original behavior. Right? So that we have seen so many times, especially let's take the example of HF. Now this HF is formed by what? Sharing of one electron from fluorine and hydrogen. Now as soon as the sharing is done, the covalent bond will be formed. But we know that fluorine has higher electronegativity as compared to hydrogen. So bonding electron pair remains more attracted towards fluorine. So it will appear like this. And these only we have discussed for last 3 classes in dipole moment, right? So fluorine has attracted the bonding electron pair more towards it. So electron density, electron cloud remains closer towards fluorine, making fluorine minus delta and hydrogen plus delta. Check it. So this charge development is actually a behavior of ionic bond or ionic compound. If it is electron sharing, there should not be any charge development, but in electron sharing, in covalent compound also charge development is there. And if charge development is there, that is a behavior of what? That is a behavior of ionic bond. So you can find the entry of ionic behavior in covalent molecule, and that is called what? That is called polarization. That is called what? That is called polarization. So such bond is called polar covalent bond, and such molecules are called polar molecules. This much we have discussed in so much depth in last 3 lectures, right? So when such things happens, when there is a bond, covalent bond formed by electron sharing, such bonds are formed between 2 atoms which have difference in electronegativity. Say if the bond is formed between fluorine and fluorine, no such electron pulling to either side will happen. Why? Because both the side atoms are fluorine only. So attractive force provided by this fluorine and attractive force provided by this fluorine will remain same. So bonding electron pair will remain in the middle of both these fluorine atoms, and no charge separation or the development will be possible. So if there is a covalent bond formed between 2 atoms which have difference of electronegativity, in that case the one whose electronegativity is more will attract the bonding electron pair more towards it, imparting partial negative charge on it, and the other will develop partial positive charge. And we have calculated with the help of numerical formula also several questions yesterday. Oh, okay. Now the reverse thing is also possible. Now what is the reverse thing? Reverse thing is there. We have seen that in covalent molecule ionic nature is developed. In ionic molecule covalent character can also be developed, and that was explained by scientist FAJAN, and that explanation is known as FAJAN'S rule. The way we have discussed the development of ionic behavior in covalent molecule, the same thing can happen, the development of covalent nature in ionic molecule. So what is the development of ionic behavior? Ionic behavior is actually a charge separation. So if charge separation takes place in covalent molecule or covalent bond, then it is called deviation or polarization in covalent molecule. But if you have an ionic bond, but in that if electron cloud remains shared between 2 atoms, actually what happens? The electron transfers from one atom to another atom. Electron transfers from one atom to another atom. The one that gives electron has a positive charge, and one the electron accepts will develop negative charge. But after that, of course, positive and negative charge will attract each other, and that attraction only is called ionic bond. Now if two ions are bonded with each other by ionic bond, and after bonding if you find that there is a sharing of electron cloud between these two ions, then that is called what? That is called a development of covalent nature. Why? Because if one is giving electron to another, that is a complete transfer, and the foundation of the bond is nothing but ionic bond. Why? Because that is formed by shifting of electron or complete transfer of electron from one atom to another atom. That forms one as a cation, the other as an anion. Okay, the cation is formed, anion is formed. Now they join with each other by electrostatic force of attraction. But after that, what happens? After that, electron cloud remains somewhat shared between this cation and anion, and that sharing of electron cloud between two atoms is nothing but what? Nature of covalent bond. So if in electron sharing in covalent molecule, if charge is developed, that is called polarization in covalent bond. But if electron sharing between positive and negative ions, if I speak positive and negative ions, the fundamental thing is what? Ionic bond. But if the electron cloud is shared between two atoms, the sharing is what? The sharing is covalent nature. So if once the electron transfer already has taken place, one has become cation, the other has become anion. Now they have been joined also with each other by electrostatic force of attraction or Coulombic force of attraction, and after that you find that there is something sharing between these two. The sharing is what? The sharing is in fact the nature of covalent bond. So if these enters in ionic bond, then that is called what? That is called polarization of ionic bond, and that polarization of ionic bond was first explained in detail by the scientist Fajan, and that is known as FAJAN'S rule. Now that we are going to discuss. Let's take the example of silver iodide. Now you can understand how this silver iodide is formed. How this silver iodide is formed. Think over it. Of course, silver has electron configuration krypton 4d10 5s1. So if this Ag loses one electron, then it will be krypton 4d10 5s0, and it will be highly stable. And iodine is what? Iodine electron configuration is krypton 4d10 5s2 5p5. If it gains one electron from this iodine, it will be Ag, so it will be 4d10 5s2 5p6. Why? Because this electron lost comes over here. So what happens in this case? Ag loses one electron, it becomes Ag plus an electron, and iodine gains one electron and it becomes I minus. Check it. Now Ag plus has positive charge and I minus has negative charge. Both will attract with each other, Ag plus plus I minus, and that will form what? Agi. This much is clear to everyone. Now you look at this Ag plus. Ag plus is a very small cation, and I minus is actually very large anion. I think I told you this is nothing but a gym ball. The size is comparable with the ball that is used in gym for exercise purpose. Now what happens? As such iodine atom, you know that fluorine, chlorine, bromine, iodine, right? The iodine atom is at the bottom almost, and if it becomes I minus, of course if you compare atomic size, then also it will be very large, and if its anion is formed, its size will be even larger. Now what happens once the electron transfers to this iodine and it becomes I minus, size being very large, nucleus of iodine is not that much capable to pull the outermost electron cloud sufficiently towards it. Ag plus being smaller in size, what happens? It is capable of attracting its own electron, but even after that the spread of the positive charge remains even outside this positive, its own boundary. So what happens now? It has a tendency to attract the electron cloud of these I minus also. So these electron cloud remains somewhat attracted more towards what? More towards Ag plus also. So now what has happened? Actually electron should be completely with I minus, but due to its large size it could not attract it properly, and Ag plus being small in size could attract it very much nicely its own electrons, as well as it could give attractive force over the outer skirts electron cloud of I minus, and due to that this electron cloud remains attracted somewhat towards Ag plus, means what? This electron cloud actually now has come somewhat between Ag plus and I minus, and when electron cloud or electron probability comes between two ions, this is nothing but covalent character. Whenever electron density or electron cloud comes between two atoms or ions, that is what? That is called sharing. Means what? This is actually the compound that has been formed by the electron transfer. So ideally this compound is what? Ideally this compound is ionic in nature. But once the compound is formed, iodide ion being very large in size, nucleus of iodine is not capable of providing sufficient attractive force over the electrons present in the outermost boundary. Ag plus being very small in size, it is capable of attracting its own electron. Not only that, the positive charge has a spread even after its boundary, and that positive charge is now providing attractive force over the electron cloud on the boundary of I minus ion, and due to that reason this electron cloud of I minus now remains pulled towards Ag plus and hence come in between Ag plus and I minus. So if electron cloud comes between two atoms, that is what? That is covalent. So what? Covalent nature has been developed in ionic. Covalent nature has been developed in ionic. Means what? Deviation from original behavior. This is what? This is nothing but polarization. So this is called what? This is called polar ionic bond. In last three classes we were used to discuss about what? Polar covalent bond. Now this is called what? Polar ionic bond. This is called what? Polar ionic bond. So you note down this much and let me know if you can proceed, and let me know that also that this is clear to you. Note down or give the chat, give the comment in the chat box that you have understood. I want each and every student to participate in chat so that I can understand. I will wait for 30 seconds if you are copying this, and then we'll proceed. And then we will come on to the point that how this polarization actually be affected. Good. Now, if I go for AgBr and AgI comparison, so in this case, what happens? Ag plus remains constant, and these are Br minus ion, and in this also Ag plus remains constant, and this is I minus. So I hope you can understand. In this also polarization will take place, and in this also polarization takes place. But before that, you should understand this is actually, both these actually are what? Both these actually are ionic compounds only, and they are produced by what? Electron exchange. They are produced by what? Electron exchange. So Ag plus gives electron, Br accepts electron, Ag plus Br minus. Ag gives electron, I accepts electron, Ag plus I minus. Now what happens once the electron is transferred? Ag plus becomes smaller as compared to Ag, and Br minus becomes larger as compared to Br. Why? Because you know that cation is always smaller than its neutral atom, and anion is always larger than its neutral atom. Now in this case you can see I atom is as such larger than Br. I minus will be definitely very large. So these Ag plus will provide attractive force over the electron cloud on the boundary of I minus, and due to that what happens, these boundary electron cloud will be attracted towards Ag plus. Now same thing, Ag plus can provide attractive force over the boundary electron of the Br minus, and that is how it can attract the Br minus electron cloud also towards it. Now can you find the difference between these two? Now what the difference is there? You know that I minus being larger in size, it will be a little less efficient to provide attractive force over the boundary electron cloud as compared to Br minus. Yeah, so you can speak reverse, that Br minus is being little smaller in size as compared to I minus, can sufficiently provide, or rather can provide better attractive force as compared to I minus over the boundary electron cloud. So its electron cloud will be attracted towards Ag plus little less as compared to this Agi. So in this case, if you want to compare, if you want to compare the polarization will be more in case of AgI as compared to AgBr. Why? In both of these, cationic size is same, but anionic size is not same. Check it. Cationic size is same, but anionic size is not same. Why? Because Br minus being smaller in size, it has its own attraction sufficient, so it will not allow cation to pull electron cloud much towards itself. And if it is not allowing much, means what? Less polarization. I minus being large in size, it has a less sufficient attraction over the electron cloud on its boundary, so it will have to allow this Ag plus ion to pull its electron cloud. And if it is allowing, means what? It shows that it has more polarization. Means what? If your anion is large in size, polarization will occur better. And if your anion is small in size, what happens? Polarization occur a little less. So if you want to compare in this case, if I write so many, like all, AgF, AgCl, AgBr, AgI, you can see in all of these Ag plus is same, but you can see this chloride is the smallest, chloride is larger, bromide is even larger, and iodide is the largest. So in this case of AgI, attractive force of nucleus of its own electron will be very poor over its own electron cloud, so it will allow this Ag plus to pull this electron cloud towards it. Means what? AgI will have maximum polarization. AgI will have maximum polarization. So polarization order will be what? Polarization order. I hope you understand this. Let me know. Clear? Understood? Please note down in chat box so that I can understand that you understood. Large size of anion, more polarization. You can note down this concept. Now I am going to put one more example in front of you. Say it is LiI and say it is CSI. Now you will have to compare this polarization. Now in both of these, I minus is same. This is I minus and this is I minus. Both are I minus. While in this case, this is Li plus and this is CS plus. Now can anyone tell me which has more polarization? Now in this case, I minus I have taken same. I minus I have taken same. But you can see this is lithium, then sodium, then potassium, then rubidium, and then cesium. So cesium itself is very large in size. Its own nucleus will be not that much sufficiently attracting their own electron. So spread of positive charge of nucleus even after its boundary will be weak in this case. But you see this Li plus. Li plus is very small in size. As Li plus is a small in size, it will have sufficient attractive force over its own electron cloud, and as its size is small, the spread of its positive charge will remain even after its boundary, so it will be capable of attracting the electron cloud of I minus sufficiently, but this Cs plus will not be attracting the electron cloud of I minus sufficiently. So what? Polarization will be what? Polarization will be large in case of lithium iodide as compared to cesium iodide. So I hope you have done the same. Let me know. It's fine. So what can be noted over here? Smaller cation, more polarization. जितना cation small होगा, the smaller the cation, what happens? It has its positive charge attracting its own electron cloud sufficiently. Not only that, the spread of the positive charge will remain even outside its own boundary, and if it is even outside its own boundary, definitely it can pull the electron cloud of nearby anion. And if it pulls the electron cloud of nearby anion, that only is nothing but the polarization, right? So smaller cation, more polarization. It's fine? Okay. Now I am going to give you one more example, and that will clear one more concept to you. I am giving you LiI and I am giving you BeI2. Both are ionic. Both are ionic. Now we look at here LiI and BeI2. So this is I minus in both and I minus in both, while this is Li plus and this is Be plus 2. This is Be plus 2. Now what happens in this case? One more thing, the lithium and beryllium, you know, lithium, beryllium, boron, carbon, as you go this direction, what happens? Not only size decreases, but this has Li plus and this is Be plus 2. Check it. So as compared to Li, beryllium is smaller in size, but listen to me carefully, but one more thing is favorable in case of beryllium is what? You know, it has 1 unit more charge also. So this is 1 unit positive, this is 2 unit positive. So not only this beryllium is smaller in size, but of course both are isoelectronic. This has 2 electrons, this also has 2 electrons. So this is going to have small size. First thing, not only small size, it will have large positive charge also. So higher the charge, higher the positive charge, of course positive charge is a tendency to what? To pull the electron cloud. So this Be plus 2 has larger positive charge, it has a more tendency to pull the electron cloud of negative ion towards it as compared to smaller positive charge. So in this case, LiI and BeI2, if you want to compare the polarization will be more in case of BeI2. So this order I am showing is what? Of polarization. So what we can note over here, let me know what we can note over here, that larger the charge, more polarization. Done? Cation has polarizing power. And anion has polarizability. You should remember this word. Anion undergoes polarization and cation does polarization. So cation has what? Cation has a power of polarizing, that is called polarizing power. And anion is now submissive, it allows the polarization, and that is called its polarizability. It's done. You will remember this. And for all of these you will remember only one thing, and that is going to be very much simple, that is small cation, large anion. You will remember these only, and that will explain you polarization. Polarization, or you can say covalent character. If you have to compare with cation, you will focus on to small cation, and if you have to compare with anion, you will focus on to large anion. That's it. You will focus on this SCLA. Small cation, large anion. Small cation, large anion. That's it. If you focus on to this, you can easily understand this. Now one very important thing you will have to remember, that was conclusion by FAJAN'S. Experimentally he is concluded, and that we are going to discuss. That pseudo noble gas configuration has more polarizing power than absolute noble gas configuration. Let me tell you, Na plus, this is argon, one S2, 2S2, 2P6, 3S0. K plus, this is 1S2, 2S2, 2P6, 3S2, 3P6, 4S0. Now you look at this, these 8 electrons in outermost 8 electrons in outermost orbit. This is what you know, this is called absolute noble gas configuration. Now I am taking Cu plus 1, that is 1S2, 2S2, 2P6, 3S2, 3P6, 3D10, 4S1 actually, but it is Cu plus 1, so definitely it is 4S0. Now if I take Zn plus 2, so it is 1S2, 2S2, 2P6, 3S2, 3P6, 3D10 and 4S2. Actually 4S2, 2 electrons are lost, then it becomes Zn plus 2. Now we look at here, these has 18 electrons in outermost orbit. This has 18 electrons in outermost orbit. If 18 electrons are there in outermost orbit, it is called pseudo noble gas configuration. Pseudo noble gas configuration. You note down this much. First of all, you should understand what is absolute noble gas configuration and what is pseudo noble gas configuration. So if any cation has 8 electrons in its outermost orbit, that is called absolute noble gas electron configuration, and any cation has 18 electrons, that is going to happen for d block elements only. If any cation has 18 electrons in its outermost orbit, then it is called pseudo noble gas configuration. And what Fajan concluded is, whenever there is a comparison between the cation of absolute noble gas configuration and pseudo noble gas configuration, it is found that pseudo noble gas configuration has more polarizing power, it has more covalent character. So if you have noted down this, we can go to the examples. Just mention done in the chat box so that I can start. Say for example, you have NaCl and CuCl, and say you have KCl, you have ZnCl2. Now you see this is Na plus and K plus, this is absolute noble gas configuration, while Cu plus and Zn plus 2, these are what? These are pseudo noble gas configuration. Why? Because in these 8 electrons in outermost orbit of K plus, 8 electrons in outermost orbit of K plus, Cu plus 18 electrons in the outermost orbit, Zn plus 2 18 electrons in the outermost orbit. So 18 electrons is nothing but pseudo noble gas or pseudo inert gas configuration, and whenever there is pseudo inert gas configuration or pseudo noble gas configuration, that ion has more polarizing power, and due to that it has a more covalent character. Let me tell you, all these 4 compounds are ionic in nature. They are formed by electron exchange. But once the electron exchange is over, polarization starts. And whose polarizing power is more? Pseudo noble gas configuration has more polarizing power as compared to absolute inert gas or absolute noble gas configuration. So polarizing power of CuCl will be more as compared to NaCl, and ZnCl2 will be more as compared to KCl. So this is for what? Polarization. So in this case you are focusing on to just noble gas electron configuration or pseudo noble gas configuration. Second thing, both confusing factors are there, size and charge. Definitely charge is always given priority. Why? Because electron pulling takes place due to what? Electron cloud pulling takes place in between two atoms, occur due to charge. So charge is always given high priority. Ionic compounds have very high melting point, boiling point, solubility in water and thermal stability. Thermal stability means what? If you give thermal energy to that compound for a long period of time, it will remain stable, it will not decompose. Melting is a different thing and to remain stable is a different thing. Okay, so ionic compounds are highly stable. Ionic compounds have very high melting point, high boiling point, they are highly soluble in water and their thermal stability is also high. Now what happens in this case, that due to polarization covalent character enters in ionic compound. So melting point, boiling point, solubility in water, and thermal stability decreases. Very important. इसके ऊपर आप जितने चांद सितारे लगाना चाहे लगा दें. Very important. So polarization is directly proportional to covalent nature, is inversely proportional to MP, inversely proportional to BP, inversely proportional to solubility, inversely proportional to thermal stability. ये बहुत ही इंपॉर्टेंट है. इसके ऊपर आप जितने भी चांद सितारे लगाना चाहे लगा सकते हैं. वेरी इंपॉर्टेंट. क्यों? क्योंकि आपको क्वेश्चन सिर्फ कोवेलेंट कैरेक्टर से पूछे ऐसा जरूरी नहीं है. वो आपको क्वेश्चन मेल्टिंग पॉइंट से भी पूछ लेंगे कि इन दोनों में किसका मेल्टिंग पॉइंट ज्यादा है. आपको वो भी पूछ लेंगे कि इन दोनों में बॉइलिंग पॉइंट किसका ज्यादा है. तो सबसे पहला आप ये चेक कर ले कि उसमें पोलराइजेशन कहां पर है. जिसका पोलराइजेशन ज्यादा है उसका मेल्टिंग पॉइंट कम होगा, जिसका पोलराइजेशन कम है उसका मेल्टिंग पॉइंट ज्यादा होगा. बोलो, ये समझ में आ रहा है? यहां तक लिख लिया हो तो मेंशन कर दो स्टूडेंट्स. चलो आप मुझे कंपैरिजन बताओ. LIF, NAF, KF, RBF एंड CSF पोलराइजेशन का ऑर्डर क्या होगा? पोलराइजेशन का मतलब कोवैलेंट कैरेक्टर का ऑर्डर क्या होगा? तो सबसे पहले तो देख लो कि फ्लोरीन सब में कॉमन है. सबसे पहले ये भी देख लो कि सब में पॉजिटिव चार्ज सेम है. लेकिन Li से सीजियम की तरफ जाओगे तो साइज इंक्रीज होगी. साइज अगर इंक्रीज होगी तो कैटायन की पोलराइजेशन पावर क्या होगी? कैटायन की पोलराइजेशन पावर डिक्रीज होगी. ठीक है, तो ऑर्डर क्या बनेगा? ऑर्डर ये बनेगा. चलो अब मैं यहां पर सिर्फ कैटायन लिख रहा हूं, सिर्फ कैटायन लिख रहा हूं. ब्रैकेट में डाल रहा हूं पोलराइजिंग पावर. polarizing power. तो ऊपर से नीचे जाएंगे, as we go down what happens, the size increases, each of these has size same, sorry, charge same, but going down what happens, size increases. This is the smallest ion Be plus 2, Ba plus 2 is the largest ion, and as Be plus 2 is the smallest ion, it has a more tendency to pull the electron cloud of the nearby ion. Definitely it will be like this. Clear? Next, F minus Cl minus Br minus I minus. Now polarizing or polarization ability. These will not polarize, they themselves will be polarized. Now F minus Cl minus Br minus I minus, what I told you, small cation, large anion. So if anion is large, it has higher tendency to undergo polarization, to fluoride to chloride to bromide to iodide. What happens? Polarization will increase. Let me take this example, LiF, LiCl, LiBr and LiI. I will ask you covalent nature. Covalent nature. Who will have higher covalent nature? So Li plus is same in all of these. So I minus will be maximum polarized. If I minus is maximum polarized, what you will see? I minus is maximum polarized. You can see it will be maximum covalent in nature. So order will be like this. Now let me ask you this question, LiCl, BeCl2, AlCl3 and one more carbon tetrachloride. Now in this you tell me what is the covalent nature. So in this all Cl minus remains same, and going from left to right two things will happen. This is Li plus, this is Be plus 2, this is Al plus 3 and this carbon is plus 4 as such. So what happens, size decreases, not only that charge increases, and due to that polarization will increase and covalent character will also increase. So it will be like this. Let's have a few more examples. Now you will tell me on which number it was. Now you let me know NO2 minus and NO3 minus. Polarization ability. NO2 minus, NO3 minus. Same way SO3 minus 2, SO4 minus 2. Polarization ability. Now you see this NO2 minus has 1 nitrogen 2 oxygen, this has 1 nitrogen 3 oxygen. Obviously this is large in size, and anion if large in size it will allow electron cloud to be pulled by the nearby cation. So this has large polarization ability. Same is the concept over here also. Same is the concept over here also. Now tell me Na2O, MgO and Al2O3. Now covalent character, covalent nature. Covalent nature. This has higher covalent nature. So in all of these O minus 2 remains same, while going from these Na2O, MgO, Al2O3, sodium has 1 unit positive charge, magnesium has 2 unit positive charge, aluminium has 3 unit positive charge. So not only charge increases, the size also decreases going from left to right. So going from left to right, polarizing capability increases, so it will be like this. Now you let me know about NaCl and ZnCl2. NaCl and ZnCl2. Now in this case, you will have to apply a special concept just I taught you 5 minutes ago. In both of these Cl minus is there. Now in this case I just told you that you will have to apply special concept. This has 8 electrons in outermost orbit. Zn plus 2 has 18 electrons in outermost orbit. This is pseudo noble gas configuration, and pseudo noble gas configuration has always higher polarizing capacity. So definitely this has more covalent character. Covalent character. Right? Now let me give you one more example. Can you try this SnCl2 and SnCl4? In this you will have to show me covalent character, or it can be asked in terms of melting point also, boiling point also. SnCl2 and SnCl4. What happens in these also Cl minus, in these also Cl minus? Check it. So what happens in this case, that this is nothing but Sn plus 2 and this is Sn plus 4. So what happens, this has higher charge, definitely lower size. Higher charge, lower size will pull. Higher charge, lower size. So smaller the cation. Smaller the cation, definitely it has a more tendency to pull the electron cloud of chloride. So this has more covalent character. If more covalent character, if you are asked what will be the status of melting point, then answer will be reversed. Why? Because this has more covalent character. More polarization, more covalent character, then what? Melting point will be lower, water solubility will be lower. Take care of this, right? I can give you one more example also. Can you try this example, FeCl2 and FeCl3? Can you give this covalent? Yeah, water solubility. Let's take this, water solubility. Water solubility. FeCl2 and FeCl3. So both of these Cl minus same. This has Fe plus 2 and this has Fe plus 3. Look at this. Fe plus 2 and Fe plus 3. Now this has Fe plus 3 has large positive charge and small size. So cation is small. Cation is small means polarization more. Polarization more means what? More covalent character. And more the covalent character, less will be the water solubility. Your answer should be this. Let me take one more example, 12 number. See PCl5 and PCl3. Let me tell you one thing. Both these are covalent. Both these are covalent. None of these is ionic. Let me tell you. Still it is asked that which has more covalent character. Both. Let me tell you. Both are covalent. PCl3 is covalent with sp3 hybridization and PCl5 is also covalent with what? With sp3 dehybridization. Still they can ask you which is more covalent. So covalent, which is more covalent? So definitely in this phosphorus has charge plus 3, in this phosphorus has charge plus 5. So as charge of phosphorus is high in PCl5, it will pull the electron cloud very strongly as compared to PCl3 with the phosphorus has positive charge plus 3. So this can pull electron cloud towards itself strongly, and due to that what happens? Due to that the polarization is more in case of PCl5, definitely it will be more covalent in nature. So answer will be this. I hope you understand. Let's take one more example. If I give you SF6 and SF4, covalent behavior. Both are covalent. SF4, I think you know it is a seesaw structure with sp3 dehybridization, while SF6 is sp3d2 hybridization. In this sulfur is plus 4, in this sulfur is plus 6. So higher the positive charge, more will be the tendency to polarize the nearby anion. So in SF6 polarization is more, and as polarization is more, definitely it has more covalent character. It goes like this. So I hope all these examples must be very much clear to your mind. All these examples must be very much clear to your mind. Let me know in the chat box that FAJAN'S rule is clear. and you always can expect one such question in your NEET or JEE exam. So when I have explained before few slides this, yes, you will remember this. Higher the polarization, more will be the covalent nature. More the covalent nature. These first three things are really very important. Higher the covalent nature, melting point will be lower, boiling point will be lower, solubility will be lower, thermal stability will also be lower. But definitely thermal stability depends on other factors also, not only on polarization. But still you can rely on these first things: melting point, boiling point, solubility. Thermal stability depends on several other factors also, that I am going to clear in next 2 minutes. So if you are clear with this FAJAN'S rule, we can shift on to the new title, that is thermal stability. Let me know. Okay, one more thing I would like to summarize, that smaller the cation, larger the anion. You will remember these only. Whenever you are asked the question regarding FAJAN'S rule, or whenever you are asked the question regarding polarization or covalent behavior in ionic bond, you will remember only one thing: SCLA, small cation, large anion. This much is sufficient for you to solve almost all the questions. It's fine. Almost all the questions are there. Of course, one more extra information is there, not much required, but still I think I should give you that. As covalent character increases in ionic compound, it appears color. Higher the covalent character, more intense or dark color is observed. Say, let me take AgCl, AgBr, AgI and Ag2S. Percentage ionic character. I hope you can understand. All these are what? All these are such in which the cation is Ag plus only. But you can see anion is chloride, then bromide, and then iodide, and then S minus 2. Right? S minus 2 has larger size, slightly larger as compared to I minus E1. So it has a very high polarizing power. Sorry, polarization ability. So what happens? Polarization increases, covalent character increases. Now you will be surprised to know that how much ionic character they have. This has 22% ionic character, this has 18% ionic character, this has 11%, only 11% ionic character. 89% it has become what? 89% it has become covalent, and that is very surprising. This has only 8% ionic character. Now we look at the color they have developed. Look at the color they have developed. This is what? This is white. AgCl is white. This is light yellow. See, covalent character has increased, ionic character has decreased, means covalent character has increased. So this has become light yellow. This has reasonably, of course it is also highly covalent, but still as compared to all of this, it is still ionic. This is dark yellow, and this is black. This is just extra information. If you can remember, that can be helpful when such questions can be asked. Now the next thing we are going to cover now is thermal stability. Now for thermal stability, you will have to find out, you will be asked this type of questions so often that you will be given 2 or 3 or 4 compounds and you will have to find out the thermal stability. First of all, let me tell you what is thermal stability. Stability against supply of thermal energy is called thermal stability. It does not mean that the substance will convert from solid to liquid. That is not thermal stability. The compound will be decomposing. If you provide thermal energy, compound will be decomposing or the bonds will be broken. That is called what? That is called thermal stability. I explain you once again, if you provide thermal energy and the substance becomes solid to liquid or liquid to gas, that is not thermal stability. If you provide thermal energy, the bonds present in the compound are broken or the compound decompose into some other compounds, that is what? That is thermal stability. If the compound is stable over a large range of thermal energy provided, then the substance is called thermally stable. But if you provide a small amount of thermal energy and that compound is broken or the bonds present in the compound are broken, then the compound is called less thermally stable. I hope it is clear. Say for example, I have two compounds A and B at room temperature 25 degrees Celsius. Now I start supplying the thermal energy and due to that the temperature will increase. Compound A only at 30 degrees Celsius decomposes or the bonds in the compound A are broken, while compound B undergoes decomposition or bonds are broken at 300 degrees Celsius temperature. So you can say that A is thermally unstable while B is thermally stable, or rather you can say more stable. I hope you understand. What is thermal stability is you will provide thermal energy to the compound, and if the compound bears that thermal energy and the bonds present in the compound are not broken or compound does not decompose into another compounds, then the compound is said to be thermally stable. Now these type of questions are asked the relative thermal stabilities. So first of all, you will find out whether the compound is covalent in nature or ionic in nature. So compound is covalent in nature or ionic in nature, that you will have to find out. There are two chances: covalent compound and second is ionic compound. If the compound is covalent, it is very easy to find out bond energy. Higher the bond energy, more the stability. Higher the bond energy, more the stability. Now if you are at ionic compound, you will have to find out two things. In ionic compound, if it is monoatomic ion or polyatomic ion? In monoatomic ion, you will focus on to lattice energy, while in polyatomic ion, you will focus on to polarization. Just now what we have studied. What about lattice energy, students? More lattice energy, more the lattice energy, more the stability. And here, more the polarization, means more the polarization, more the covalent character, less the stability. If you remember this much is sufficient to derive anything. Just learn this chart. This is enough. First of all, you should search for stability. First of all, you should search that the compounds you are given are ionic compounds or covalent compounds. If all compounds are covalent, you will find out the stability of that covalent bond. More the stability of that covalent bond, more the thermal stability of that compound. Means bond energy I have written means stability of the bond. Second thing, if your compound is ionic in nature, you will find out the ions present in that are either monoatomic or polyatomic. Monoatomic or polyatomic. If monoatomic ions are there, you will focus on to lattice energy. Lattice energy is related with two things, I think you know, that is charge, higher the charge and smaller the size. Higher the charge, smaller the size, more the lattice energy. More the lattice energy means more strongly binding. More strongly binding means what? More stability. This lattice energy we have discussed earlier in the same chapter, in the second or the third period of this chapter only. This is going to be, I think this is 28th or 29th lecture of this chapter. This much detail I don't know any other teacher or any other institutes are teaching this chapter in this much depth, and still it's going on. Okay, polyatomic ion. If ions are made up of more than one atoms, then it is called polyatomic ion. In that case, you will focus on to polarization. If polarization is there, means what? It has a covalent character, and if it is a covalent character, it has less thermal stability. It has less thermal stability. Okay. If I take the example of HF, HCl, HBr, HI. First of all, you should recognize that all these compounds are covalent in nature. All these compounds are covalent in nature. This is formed by 1s 2p orbital overlap. This is formed by 1s 3p overlap, 1s 4p overlap, 1s 5p overlap. Look at this. So if you look at this, you can understand this 1s 5p overlap will be very poor. So this bond will be poor, and if the bond is poor, definitely if you provide thermal energy, this will be broken very easily, and the order will be like this. Sorry. The order, thermal stability order will be like this. I hope you should understand. Now if I give you example of NH3, PH3, ASH3, SBH3, batao. Now in this case, the overlap between what? This nitrogen is small in size, though the bond will be formed very easily. PH3, ASH3, SBH3, the bond will become weaker and weaker, so that thermal stability will be in this order. Okay, give me the answer of this question. Give me the answer to this question, students. Thermal stability answer, students. Of course, it goes like this. Okay. Now explain me this. You will have to apply your brain little bit. Of course, you should apply that this has a triple bond, this has a double bond, this has a single bond. So single bond can be broken most easily as compared to double bond, as compared to triple bond. So the thermal stability will be like this. Remember this. Okay, now I am giving you one very interesting question. You have benzene and you have cyclohexane. Which one will be more thermally stable? Let me know. This is the question, very smart question, and more than 99% student commit this question or make this question wrong. Let me explain you first and then you will apply. Focus on to this. This is benzene in which these bonds are there, while these is cyclohexane and all these are hydrogen atoms, right? So in cyclohexane all are sigma bonds, while in benzene carbon sigma bonds, that already are there in these also, right? But in this case what happens, only one carbon hydrogen sigma bond is there, while in this case each carbon atom has two carbon hydrogen sigma bonds are there. So though you can find okay, in benzene there is resonance and resonance provides high stability, of course it's correct. But in cyclohexane number of sigma bonds are more as compared to this. As compared to sigma bond, as compared to pi bonds, sigma bonds are thermally more stable. Remember this always. So what happens in this case? Stability order in this case is going to be this. Cyclohexane is more thermally stable than benzene. Take care. Now let me give you one more example. Now from this you can understand, and now you can apply your brain even better. Now in this case check it. Which one is more thermally stable? Now we focus on to this. Both these are such in which the number of sigma bonds and number of pi bonds are same. Number of sigma bonds and number of pi bonds are the same. So when you have same number of sigma bonds and same number of pi bonds, in that case you will check the resonance. In this no resonance, check it. A double bond B, C has nothing, while this has A double bond B, C double bond D. Both have equal number of sigma and pi bonds, and in that case what you will remember, the one, first of all you should check, they should have equal number of sigma and pi bonds. If they have equal number of sigma and pi bonds in organic compounds, you will focus the one which has resonance will have more stability. So our answer will be this. Let's have these compounds. CH3 for other, CH2 double bond CH, CH2 CH double bond CH2, and CH3 CH double bond CH, CH double bond CH2. You look at this and tell me which one is more stable, up or down. Which compound is more stable, upper one or lower one? First you check, both of these have same number of sigma bonds and pi bonds. Of course, both of these have same number of sigma bonds and pi bonds. Check it. A double bond B, C has nothing. A double bond B, C has nothing. Okay, in this case A double bond B, C double bond D. So lower has resonance, so lower one will be more thermally stable. Okay. One more thing I let me explain you. They can ask the stability between these phosphorus also. Of course, in diamond and graphite. In diamond and graphite, if you provide thermal energy, the one which will decompose easily will be definitely graphite. Sorry, graphite is less stable. If phosphorus are there, white, yellow, red, and black phosphorus, so definitely black is more stable. These are practical. कभी पूछ ले तो आपको याद रखना है. ठीक है स्टूडेंट्स, चलो. दिस इज अबाउट डीकम्पोजिशन टेक प्लेस. टेक केयर. डीकम्पोजिशन के बेसिस पर ये ऑर्डर लिखा है, स्पेशली फॉर डायमंड एंड कार्बन, डायमंड एंड ग्रेफाइट. Now we'll come to ionic compounds, and that is going to be very much interesting. Let me give you LiCl, NaCl, KCl, RbCl and CsCl. What is your comment on this? These all are, first of all, you should realize that all these compounds are ionic in nature. If these compounds are ionic in nature, I think you should be able to distinguish whether these are monoatomic or polyatomic. Definitely you can see the monoatomic, chlorine, monoatomic. If it is monoatomic, you will apply what? Lattice energy. If you apply lattice energy, you will check the size and you will check the charge. If all are chloride, you will not focus on chloride. You will focus on what? Lithium, sodium, potassium, rubidium, cesium. Charge. Each of these has one unit charge. Each of these has one unit charge. If each of these has one unit charge, what you will do? You will take the size. Li plus has the smallest size, and Na plus K plus Rb plus Cs plus are increasing in size. Size increases, lattice energy decreases. So these has highest lattice energy. The order will be like this. Second, LiF, LiCl, LiBr, Lii. Let me know. Thermal stability. Thermal stability. Now in all these lithium is constant. In all these lithium is constant. Fluoride, chloride, bromide, iodide are different. Due to that, what happens? All have same unit negative charge, but in this case, if you go from fluorine to chlorine to bromine to iodine, what happens? Size increases, so lattice energy decreases. Lattice energy decreases, so stability order will go like this. Check it. Li2O, Na2O, K2O, Rb2O and Cs2O. Let me know. In all of these, oxide is same, and if oxide is same, I think you know that it is monoatomic, and as it is monoatomic, definitely you will have to focus on to lattice energy. Li plus being smallest in size, lattice energy will be highest, so order is going to be like this. Give me the answer. LiH, NaH, KH, RbH, CSH. Once again, hydride ion is same. If hydride ion is same, you will have to focus on cation. Li plus, Na plus, K plus, Rb plus, Cs plus. Size increases, lattice energy decreases, order is going to be like this. Okay? 5. Let's take Li2O. Sorry. Li2O, BeO. Okay, wait. Na2O, MgO, Al2O3. Show me stability. SiO2 even you can take. So if this O3 is there, you should not consider this is polyatomic. All these have O minus 2 ion. Take care. It's fine. Okay, so what happens going from left to right? Na plus is there, Mg plus 2 is there, Al plus 3 is there, Si plus 4 is there. Check it. Going from left to right, what happens? Of course, take care. This is what? This is monoatomic ion. And whenever it is monoatomic ion, for thermal stability, you will focus on to lattice energy. Take care. In this case, you are not going to apply polarization. Take care. So what happens going from left to right? Na plus 2, Mg plus 2, Mg plus 2, Al plus 3, Al plus 3 to Si plus 4. Not only size of cation decreases, but the charge also increases. If the charge increases, lattice energy increases. If lattice energy increases, order will be this. Now let me give you few more example, and that will clarify the concept even better. 6. Let's have this: beryllium carbonate, magnesium carbonate, calcium carbonate, strontium carbonate, and barium carbonate. Now the entry from this example is polyatomic ion. Can you understand? Carbonate is made up of 1 carbon and 3 oxygen. 1 carbon and 3 oxygen. So see, this is polyatomic ion carbonate. And here if it is beryllium, then magnesium, then calcium, then strontium, and then barium very large. So this small size Be plus 2 can carry out the polarization of this carbonate very effectively. But as you go down, what happens? This size increases, and as size increases, small cation, large anion. If the size of cation is small, polarization is more the polarization, less thermal stability. So order will be this. If you are clear with this concept 6, question 6, you should note down 6 clear. See students, I have made this concept very much easy for you. Very much easy for you students. So this is polyatomic, right? Nitrate is also polyatomic. If it is polyatomic, you will focus on to polarization. Polarization, what you will see in the polarization, now you don't have to focus on to nitrate. Once you have determined, once you have defined that nitrate is polyatomic, you will have to focus on to the cation only. Small cation, more polarization. More polarization, less stability. So stability order will be like this. If I say LiOH, NaOH, KOH, RbOH, and CSOH, check it. What you will do? What you will do in this case? In this case, you can check OH is also polyatomic. Why? Because O and H, 2 atoms are there in negative ion. So as it is polyatomic, you will apply the concept of polarization. So OH is saying Li plus smallest in size, highest polarization, lowest stability. So the order is going to be like this. But if I give you the example like this, like NaNO3 you have, and then you can have MgNO3 twice, and then you have AlNO3 thrice. Now we look at this. In this case also it is polyatomic, right? Nitrate, nitrate, nitrate. Now what you will see? You will see which one is lower in size. See, it is Na plus, this is Mg plus 2, and this is Al plus 3. So not only Al plus 3 is smallest in size, it has largest charge also. So higher charge, small size, it will provide more polarization. And as it provides more polarization, more the covalent character, less will be the thermal stability. It will be in this order. Ninth one clear to everyone? Let me know. Ninth one clear to everyone? Ninth clear, right? Okay, if ninth is clear, give me the answer of these then. Sorry. If ninth is clear, give me the answer to this then. What will be the answer? Apply your brain and let me know. So this OH is also what? OH is also polyatomic ion. So you will apply the concept of polarization. Na plus 2, Mg plus 2, Mg plus 2 to Al plus 3, size decreases, charge increases, polarization increases, covalent character increases, so stability decreases. So order goes like this. Clear to everyone? Okay. Now I am going to take Li2O2, Na2O2, K2O2, Rb2O2 and CS2O2. Let me tell you, all these are peroxide. Now this is very important. As it is peroxide, you must be knowing peroxide is O single bond, O has minus, and ultimately it becomes O2 minus 2. O2 minus 2. What you will say? This is monoatomic or polyatomic? This ion is made up of 2 oxygen atoms, and definitely as it is made up of 2 oxygen atoms, these will be served as what? Polyatomic. These will be served as polyatomic. So as it is polyatomic, what you will see? As it is polyatomic, you will see the polarization. In this case, Li plus is smallest in size. As Li plus is smallest in size, it will provide maximum polarization, maximum covalent nature, minimum stability. So order is going to be like this. Now similar, not same. LiO2, NaO2, KO2, RbO2, CS02. This is called superoxide. And superoxide is O2 minus, and this is also made up of 2 oxygen atoms, and these also comes under poly. These also comes under what? Poly. So in this also you will check what? In this also you will check polarization. Li plus smallest in size, it will create maximum polarization, maximum covalent nature, minimum thermal stability. So order will be like this. Now see, this is very important. You mark this. This is very important. Why so? Only because let's go to previous one. You see this. If it is oxide, maximum thermal stability of Li2O, this is oxide. See this. See question number 3 in your book. And now come to the question number 11 and 12. If it is peroxide or superoxide, least stability is of lithium peroxide and lithium superoxide. See the beauty. Why this changed? See, the concept I have given, if you have digested, then you can understand it and solve it very much clearly, without any fumbling or confusion. And this is the beauty, I tell you, if you study with me. I have simplified it in just 3 sentences. First of all, you find out what is the nature of your compound. If it is covalent or if it is ionic. If it is covalent, you check the strength of bond. Finish. More the strength of bond, more will be the thermal stability. And if you fumble in organic compound, first you find out which one has more number of sigma bonds. The one which has more number of sigma bonds, definitely its thermal stability is more. And if both them have the same number of sigma bonds, the one which is with resonance has more stability. Fine, it's over. Now if your compound is ionic, you check its ions are monoatomic or polyatomic. If it is monoatomic, you go for lattice energy. Smaller the size and higher the charge, more will be the lattice energy. More the lattice energy, more the stability. Smaller the size and larger the charge, lattice energy is more. That we have discussed at least for one whole period. We have discussed lattice energy, I think even more than that. So this much you should remember, right? So if more the lattice energy, how it will come? Less the size, more the charge, more lattice energy, more thermal stability. But if your ion is polyatomic ion, you forget lattice energy, you go for polarization. Who will do polarization? Of course, cation will do the polarization. Small cation or large charge, small cation, large charge of cation will do more polarization. More polarization, more covalent character. More covalent character, less will be the stability. That's it. Let's revise once again. You see the compounds, find out whether covalent or ionic. If it is covalent, you check the strength of bond. Stronger the bond, more the thermal stability. Compare the organic compounds. The one which has more sigma bonds, more thermal stability. If same number of sigma and pi bonds, check the resonance. The one with resonance, more stability. Further, come to ionic. Ionic, monoatomic ion, polyatomic ion. Monoatomic ion, you focus on to lattice energy. More the lattice energy, more the stability. How you check the lattice energy? Small the size, large the charge. Lattice energy will be more. Lattice energy more thermal stability. Right? The previous examples, previous screen examples, right? Now on these screen examples, we have taken polyatomic ions. More the polarization power. How you will check? Smaller the size of cation and large the charge of cation will have more polarizing capability. So polarization power will be more. So large the polarization power, that will come from what? Small size of cation. Small size of cation, more will be the polarization. More polarization, more covalent nature. More covalent nature, less thermal stability. So I hope today we took two things. One is the FAJAN'S rule. Small cation, large anion, that much is enough. And more the covalent character, less will be the melting point, boiling point, solubility, and less will be the thermal stability also. That is all about FAJAN'S rule. In FAJAN'S rule, one more extra added concept is there. If you have two cations, one with pseudo noble gas configuration and the other with absolute noble gas configuration, the one which is with pseudo noble gas configuration has a higher polarizing power. So it has more covalent character. As the covalent character in ionic compound increases, the color of that ionic compound becomes more and more intense. That also I have explained you with the examples, right? And later on we have discussed about the thermal stability. I have given so useful hints, I can't say and emphasize enough. But how do you like these hints and FAJAN'S rule? Let me know. I passed on yesterday one sheet in which you don't have to solve the two sections, otherwise the rest of the sections you can solve for upcoming exam, and that will really help you. If you have any doubt, definitely you can share with me, right? And please don't post anything to me as a doubt or anything after 10 p.m. I tell you, I told you in the last to last class also. देखो मैंने आप लोगों को क्वेश्चन दिया था डेयरी मिल्क सिल्क वाला, राइट? और मैंने बताया था कि आप मुझे रात को उसी दिन मैंने बताया था कि रात को आप मुझे कुछ भी पोस्ट ना करें. फिर भी कुछ स्टूडेंट्स ऐसे थे. एक स्टूडेंट था जिसने 147 AM मुझे क्वेश्चन पूछा. किसी ने 11:45 क्वेश्चन भेजा, किसी ने 11:47 पर पूछा कि व्हाट इज द डेडलाइन टू सबमिट द आंसर ऑफ डेयरी मिल्क सिल्क. Now, do you think 1:47 AM is the time to WhatsApp any teacher? Some students post me at morning 4 AM, 4:30 AM. It's a different thing. I daily wake up at 3:30 AM. It's a different thing, and I see the post many times, right? But means at 1:47 a.m. or 11:45 or 11:47, I give you the last instruction, please don't do that. So चैट बॉक्स में किसी ने लिखा था कि यस सर तो भगवान है, किसी भी समय आप देख लो तो बुला लो तो वो डेफिनेटली हाजिर हो जाते हैं। तो फिर मुझे ऐसा ना लगे कि कभी कभी तो अपन को लगता है कि अपन ही भगवान है, ठीक है ना, तो ऐसा नहीं है। तो अगर मेरी सटक गई तो मैं वो बंदे को, किसी ने भी अब 10 PM के बाद मुझे कुछ भी पोस्ट किया ना, तो मैं उस बंदे को 1 महीने के लिए ब्लॉक कर दूंगा, फिर पूरे लटक जाओगे आप लोग, ठीक है। चलो, तो आज की क्लास में आप लोगों को मैंने जो कुछ भी पढ़ाया, आप लोगों को कैसा लगा, प्लीज शेयर योर एक्सपीरियंस इन चैट बॉक्स, comment box and in my personal inbox, especially those students who have already studied everything somewhere else. Now the hints I have given to you, I hope you have liked it very much, but I want to know that how much helpful it is. Okay, thank you so much, keep learning, enjoy chemistry. Jai Hind, and we are meeting in the evening session for organic chemistry, most awaited question of dairy milk cell. Thank you, have a great day.